Okay, so for problem 59, it's a little bit tricky because you need to calculate the metabolic power needed for a hiker to go up a 7% slope at 5 kilometers per hour. It's a 68 kilogram hiker, so you need to kind of visualize this as a triangle, and the hint is that you can model her power needs as the sum of her power to walk on level ground plus the power needed to raise her body by the appropriate amount. So I set that up as total power equals the power needed to walk on level ground plus the power needed to raise her body to that amount. So PH plus PG. And from the table, we'll see that 380 watts is the power needed for her to walk on level ground. So when we set up this triangle, we can do tan theta is equal to the 7% slope, which is 0.07, as you can see here. And when you can solve for that, you get 4 degrees. And then with that, from there, we need to find the height of this slope. So the height can equal the distance times sine of that 4-degree slope. Because in SOHCAHTOA, the sine is the opposite over adjacent. And so we'll need to find the potential gravity energy, potential gravitational force, and that will be the mass times the gravity times that displacement times the sine of 4.0. And once you have that set up, you can have the overall human efficiency of 0.25 equal to that potential over the chemical energy. We can manipulate that to be the chemical energy needed times equal to 4 times the mass times the gravitational force times the distance times sine of 4.0 of that height for that slope. Then you can set up this equation where the potential or the power needed to go up that amount is equal to the chemical energy over change in time. And remember that any distance over change in time is equal to velocity. So we will then manipulate it to 4 times mass times gravity times velocity times the sine of 4 of that slope. Then once you plug in all your numbers, and remember you'll need to convert that 1,000 meters to kilometers, and also that hour into seconds, and you will get 259 watts. So then you can add the 380 watts given plus the 259 equals 639 watts total.